Hello everyone, you're welcome to this week's Tech Tuesdays webinar on Informatica 10.5.x CICD features. I'm Rinda, your host for today's session, and we have Puneet Sharma, Product Specialist of Global Customer Support, as the presenter for this webinar. Before we start, let's go through some housekeeping tips. This webinar is for 1 hour that includes a 15 minutes Q&A. You can post your queries in the Q&A box. Dial-in participants are muted for the entire session. The session is being recorded like all Tech Tuesdays webinars and will be available in the Informatica Support YouTube channel and the Success Portal, where you will also be able to download the slide deck. Please feel free to put in your feedbacks and suggestions for the session in the post-webinar survey. The Tech Tuesdays webinars are hosted within the Success Portal, which is a micro-learning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Puneet. Thank you.
Thank you, Vrinda. Hi, everyone. I welcome you all to today's presentation on Informatica 10.5.x CICD features. Here is the agenda of today's presentation. We'll start with the brief introduction about CICD, the design, deploy, test framework, and separation of the Informatica object in the terms of the CICD. We'll also cover what is new in the 10.5.x. Then we will move towards the entire ecosystem. We'll talk about the issue tracking system, the version control system, the integration tools, and the trigger points. In this presentation, we will also cover a very basic demo in order to understand how to implement CI/CD. So let us start with the very basic introduction about CI/CD. So the first question which comes itself is, what is CI/CD? So CI/CD is a method of delivering the frequently developed application to the customers by introducing certain kind of automation into the stages of the application development. So in order to understand this statement, it can be visualized as a designing some object, frequently making certain changes into those objects and automatically deploying it into the production by introducing certain kind of automation techniques. So CI/CD can be visualized as a design, deploy, test framework. So the separation of the CI/CD is basically in two parts. One is continuous integration and another one is continuous delivery. So the continuous integration step involves mostly the design related operations. So for example, if we go to developer client tool, connect to the MRS and develop some mapping, this basically involves the design operations, and that comes under the continuous integration. Another example would be making certain changes into already developed mapping. So continuous integration involves the design step, and the same way the deploy and test steps are basically covered under the continuous delivery. So the delivery is always built on top of continuous integration. So the entire pipeline will be, first the developer will be making certain changes to some object, and those changes will be delivered to the production in order to test that logic. So in order to implement the CI/CD, definitely we need certain kind of automation, or in order to implement that automation, there can be various pipeline. Pipeline can be visualized as a logic to implement the CI/CD. So here is a brief high-level overview of this design, deploy, test framework. So on the left-hand side, we have the continuous integration stage, and on the right-hand side, we have continuous delivery stage. So in the continuous integration stage, we develop or design certain object which will be persisted into either MRS or in the version control system. Then they are moved to the continuous delivery phase by deploying those objects as an application for the testing or for the release. And this cycle continues. Now comes the another question. What is design and what is runtime object? Specifically in terms of Informatica. So we can see that on the left hand side, if we go and connect to any model repository service, if we develop some mapping, some object, some physical data objects, those are termed as a design time object. On the other hand, once those objects are deployed as an application, they become runtime object. So underlying what exactly happens when an object is deployed as a runtime application. The moment when an object is deployed as an application or runtime object, a copy of same object will be created and it will be migrated to the runtime environment area and deployed under one particular data integration service as an application. So the runtime copy will be altogether isolated from the design time copy of the same object. So any changes made after the deployment or after creation of the application to the design time object will not be reflected back to the runtime object until unless we do not redeploy the same object. So these are a couple of the important points in order to understand the design time and runtime object. So when a developer added some object in the developer client tool, those are the design time version of the object. However, once they are deployed as an application, they become the runtime object by creating a copy of the same design time object as a runtime copy. So this is a view from the developer client tool in order to understand what exactly these design time and the runtime objects are. So on the bottom, we can see we are connected to a MRS and we have project with the name as Arita, and there are certain physical data objects, certain mappings, and there are certain applications. These all are the design time objects. However, on the beginning, we can see that we are connected to a DIS and we are connected to one particular application under which there are certain objects. Those are runtime objects. A runtime object always will be associated with one particular data integration service. So in developer client tool, we have a feature to connect to the data integration service and list the runtime object. As we can see that there are two copies of incremental application. One copy is runtime application and another one is the design time copy. They both are isolated to each other. Any changes made to the design time object of incremental application will not be reflected to the runtime copy of the application unless until we do not redeploy it. There is another feature called as a tagging, which we can see on the right hand side. This helps us to tag certain objects in order to query them for a particular purpose. Let's understand what are the features available in terms of the continuous integration in Informatica. So the continuous integration, as we understood, this involves the design time object. So most of the features are related to the design time object operations, which are provided by the Informatica. So for example, we can query the design time object. We can compare the object. We can do check-in, check-out. We can also undo and unlock the object if the version control system is configured for one particular MRs. As I said, we can do a tagging. We can also do an untag and replace the object tags. But tagging, as I mentioned, is one of the powerful features which can help us to identify certain object based on the tag name. It is giving a particular name to a set of objects which can be later used to filter those objects via command line or via API calls. So this is, for example, this is one of the continuous integration functionality. This is about querying the design time object. So in this, we can write certain query to filter some of the object based on the name of that object, the creation time, or the last modified time. We can also query the folders and the project, and we can build those query in order to perform certain kind of filters. The filter object can be later used with various purpose. It can be used to deploy it as an application or perform certain changes or to perform comparison operations. The same way we can filter those objects based on the check-in or checkout time or the version status. Now let's understand the features available in Informatica in terms of continuous delivery. So we understood the continuous delivery involves the test and deploy stages. So continuous delivery is mostly related to the runtime object, and the same way the features also revolve around the runtime object. We can perform query to those objects. We can do start and stop of an application. We can also perform the deploying and undeploying of application. We can perform patching of one particular application, and more of the operations related to the application can be performed, including the listing of application and the renaming. So there are certain commands which are mentioned and highlighted as an InfraCMD only. These features can be only supported if we are implementing the continuous delivery via the InfraCMD commands. For example, this is the feature to query the runtime object. We can filter the objects based on the name or based on the application, which can be later used to perform certain operations. Now let's understand how the functionalities of continuous integration and continuous delivery is exposed to the end user in order to consume. So there are majorly two interfaces which can help us to implement the CI/CD features in order to build one particular pipeline. So the first interface is the REST endpoint for the DIS. So this is basically providing a REST API to perform certain operations related to the runtime object. We can perform operations related to the object, related to the application, or to the mapping service. Going forward, we will see where to locate this REST endpoint capabilities on the DIS. Another interface which is available in order to implement the CI/CD is InfraCMD command. A number of commands are available, including the patch application, deploying the application, starting or stopping the application, and many more. A command reference guide for the 10.5.x version will explain all these commands in detail, along with the parameters. As we discussed, there are two interfaces. One is InfraCMD and another one is REST API in order to implement the CI/CD functionalities. Let's talk about the comparison of these two interfaces in terms of certain metrics. So the first metric which we'll be trying to understand will be the performance. So InfraCMD is always native to the processes and the services. So when compared to REST API, InfraCMD in performance wise will definitely be perform better. The second metric we will talk about the setting up the client. So as we discussed, the InfraCMD is always a native and it comes as a binary. So InfraCMD always requires installing the binaries. However, the REST APIs are not something which is dependent on any of the platform, and it does not come with any of the binaries. So REST APIs are lightweighted in nature. However, the InfraCMD always requires installation, either the server installation or the command line utility installation altogether. The third metric will be the functionality. So InfraCMD functionalities which are related to the CICD are always a superset to the REST API functionalities for CICD. So as of now, there are certain functionalities which are there in the InfraCMD command, but not part of the REST APIs. A reference to command reference guide can very well explain that point. Going further, we will see that what all functionalities are available as part of the REST API. Now coming back, what is new to the 10.5.x? So the first command which is available is called as a compare object. Now it can compare the object across the data integration service, also across the domains. The second functionality which is new to the 10.5.x is called as a query parameters. So in 10.5.x, we can use the type and object parameters in the InfraCMD commands in order to filter the design time objects. As we discussed, very basic building blocks about the CI/CD and the interfaces available in Informatica in order to implement the CI/CD. Let's understand the entire ecosystem and how we can implement the CI/CD in Informatica. So this is one of the high-level view of implementation of CI/CD. We have four major components, starting with the issue tracking system, which will help to track what all issues are there, who is responsible for managing those issues, and what is the state of that issue. The second component is version control system, which can be added to the model repository service to manage the historical changes to one particular object and keeping multiple copies of the same object for a period of time. Third and important component is integration tool, which provides certain pipelines to perform certain operations and integrate with the Informatica to exploit the interfaces available for the CI/CD. And the core of all this ecosystem is the triggers. How these individual components will interact with each other will be decided by the triggers. So let's start with the issue tracking system. A very good example of issue tracking system will be a Jira. It will help us understand the status of one particular issue, building the understanding about the issue, the stakeholders, and various other important information about the issue. A very easy example would be to implementing one particular mapping. We can raise an issue and assign it to some particular developer who will be responsible for implementing that mapping. Going forward, we will see that how we can achieve that task. Now, with the Jira being an issue tracking system. That's another important component about the Jira is how this will integrate with other tools, specifically the integration tool. So Jira comes with a trigger point called as a webhooks, which we can configure to make HTTP requests to one particular integration tool so that it can listen and understand what Jira is trying to change. Now, the second important component which we just discussed is version control system. So in MRS, we can configure the version control system. The classic example would be the GitHub or the GitLab. This will help us to understand a historical copies of the same object, which can be reverted from the developer client tool. Now, as we discussed, one of the another important component is integration system. A very good example for the integration system will be Jenkins. This can be used to automate the entire workflow. Jenkins also comes with a trigger point called as a build triggers, which can be configured to listen what Jira is trying to say and perform certain operation based on the nature of the request. We will understand the entire ecosystem as part of the demo. So the process will start when somebody raises a new Jira. It will be notified to the corresponding stakeholders. Then it will be assigned to one particular developer. Developer will be making certain changes or developing some new mapping. He will go back and change the state of the Jira. And the moment he will change the state of the Jira, there will be some automation which will be running and the code will be built and it will be deployed, either for the testing or in the production environment. And that's how the cycle will complete. Now let's go back and try to understand the demo. So here, this is one of the interface for the Jira. And I have created one issue which says that to create a mapping to filter premium order. So for the demo purpose, what we have configured is to implement a logic to filter the transaction order if the order contains a value of greater than $500. So this Jira is raised. If we want to view the workflow of this particular Jira, we can click on the view workflow, and this is the entire ecosystem we can understand. So the moment when the Jira is raised, it comes into the new state, and then it will be assigned to some developer, and it will go to the under development phase. Once the developer is able to commit the changes, he will change the state to the review, and the reviewer will go and he will check the changes, whatever the developer has developed. And based on that, either he will say that review code is successful or it is failed. So if it is failed, it will again go back to the under development phase. But if it is passed, then it will go to the test phase. In the testing, the same logic will be tested with the higher load of the data. And based on the outcome, either it will go to the under development phase or to the release phase. In the release phase, the same logic will be deployed to the production environment. And that's how the cycle will complete. So for the demo purpose, we have created two environments. One is called as a pre-prod, and another one is called as a production environment. So with corresponding to this particular workflow, once a mapping comes from the under development to the review code, and the reviewer reviews it, and the moment he says that the review code is successful, it goes into the test stage. The moment this particular issue becomes in the test state, there will be an underlying pipeline which will be triggered, and it will identify the mapping, and it will deploy it, the same mapping, into the pre-prod environment. Once the testing is completed and the status is moved to the release, the same mapping will be migrated to the production environment in order to be released. So let's see how it works. So this is the new state of this particular issue. So we are in the new state. Now I am assigning it to some developer, and I'm saying that this particular Jira issue is assigned. And the moment I said that it is assigned, it becomes in the under development phase. Now, as a developer, I will go to the developer client tool. I will develop certain logic. So here in this case, we are filtering out all those orders which are having a value greater than $500. And we are writing it to some target and calling that target as a premium orders. Now this mapping is developed. As a developer, I will go and I will say that this development is completed. And the moment the development is completed, it goes in the review code status. Now the reviewer will go and he will check the logic. He will perform certain test cases, either running a data preview, checking the data, or understanding the logic. And once the review is completed, based on the outcome of the review, the reviewer will say whether the review code is successful. So for example, here I'm saying the review code is successful. And the moment I say that the review code is successful, it goes in the test state. Now let's see what has happened, which pipeline has triggered once the code is deployed for the testing. So the moment when I made the Jira to go in the test state, I can go to the DIS in the pre-prod. I can check that this particular mapping must have deployed in order to test. We'll wait for pipeline to complete. Now here we can see that this application is visible in pre-prod environment in order to test. We can see that that is the same mapping. And this is in the running phase. Now this mapping can be tested with a high set of data. Once the testing is completed and the tester is fine with the outcome, he can go and he can say that the testing has completed. And once the testing is completed, this goes into the release stage. The moment this Jira is moved to the release state, the code which was available in the pre-prod, this will be migrated to the production environment. And we can go and we can check the application under this particular DIS to check that if the code is available or not. We will wait for the pipeline to complete. I'm refreshing the application tab. So as of now, we can see that this application is now available in the production. So once the application is available in the production, we can go and we can say that the code is released in the production. And that's how the entire cycle has been completed, starting from the new to the done. Now let's understand how it is working. So as I mentioned in the slide, there is something called as a webhook in the Jira. So under the system, if I go to webhooks, I have configured this webhook to be triggered whenever there is a change to the Jira and send that request to a Jenkins. Now let's understand where this Jenkins resides. So this is our Jenkins, which is integration tool. So in this Jenkins, we have two pipelines. One is called as a deploy to test, and another one is called as a deploy to prod. So let's go to the deploy to test. We can go to the configure to understand what is the logic this is running. So whenever there is a change from the Jira, a request is made to this Jenkins via this webhook. Now let's go to the Jenkins. And here we have configured something called as a build trigger. So this pipeline will trigger whenever there is a request from the Jira and the status of that request is test. It will capture the mapping name and the application name, which is mentioned as part of this Jira. Which is supplied by the developer. And based on that, it will trigger a pipeline on a node called pre-prod CICD. And what is the operation this is performing? The first operation it will perform is called as export. So it will export the mapping which the developer has developed, and then it will deploy the same mapping on the DIS. We can see the run, the last run which has triggered. So if you look at here, right, this is calling one script called as export.sh on the pre-prod node with the application name and the mapping name as an argument. And then this is deploying the same application to the DIS. Same way, deploy to prod pipeline is configured. If I go to configure, if I go to build trigger, this will be triggered whenever a Jira request coming and the state of the issue is released. So what it will do, it will capture the mapping name and the application name, and then it will run a pipeline on the prod environment. What it does is download the export file from the pre-prod environment and then deploy it to the production environment. We can see that same for the last run. So here we can see that we are downloading some mapping export from the pre-prod, and then we are deploying it via some script. Now let's go back to the pre-prod environment where these scripts are placed. So here we can see that there are two scripts which are placed in the prod. Let's go back to the pre-prod. In pre-prod also there are two scripts which are placed. So as a mapping Jenkins pipeline, if I go to the deploy to test, which will be running on the pre-prod environment. So I go to configure, I can very well see that in the pipeline, in the export, we are calling this export.sh script with the application name and the mapping name as a parameter. Let's try to understand what this export is trying to implement. So in the export, we are configuring some of the objects, and then we are calling an infacmd tag command, which will filter out certain design time object based on the mapping name. And then later, the same tagged option can be used to deploy those objects as a file. So here we can see that we are using the same tag to deploy those tagged objects as a file. So once this script completes, there will be a file which will be generated on the pre-prod. Once this PIR file is generated, in the deploy, we will be calling the deploy.sh here. So let's see what is there in the deploy.sh. So in the deploy.sh, we are simply calling a deploy application command by pointing the same PIR file towards one particular DIS. And that is how the code will be deployed to the pre-prod environment. These two scripts will be called via the Jenkins in the pre-prod. Now let's see what is there in the prod. So in the prod, there are two stages. One is export, which is calling the copy export file.sh. Now let's see what is there in this copy export file.sh. So there's nothing but simple sftp command to download the same PIR file which was generated in the pre-prod. So call to copy export file.sh will copy the mapping.pir file from the pre-prod to the prod. And once this is copied, in the deploy stage, we will be using this PIR file to deploy to one particular DS in the prod. So if I go to deploy prod.sh, I can see that there's a deploy application towards the same PIR file pointing to the production DS. So that is how the ecosystem is built in order to perform this particular operation. Now, we have discussed about the InfraCMD as part of our demo. Now let's discuss about the REST API interfaces. So if we go to this particular DIS and click on the processes, we can see this REST API documentation properties. If I go and click here, I would be getting the REST API documentation. So here we can see that there are certain operations which are visible and which can be implemented as part of the REST API. For example, these are the REST API calls which can be used to interact with design time repository object. runtime application object. You can also interact with the mapping service, utilities, and many more operations. We can make calls from here also. If we click on any particular operation, we can understand about what all parameters are needed here. And we can also say, try it out. And the moment I say try it out, we will get an option to specify these parameters. And it will build me a curl command along with my parameters. This is the query which we have mentioned, highlighted in our slide. So that is how we can get the curl command. And this can be used further via these scripts or via the Jenkins pipeline itself. So these are the two interfaces available in order to exploit the CI/CD features in the Informatica. Now going back to the version control system, in the model repository service under the properties tab, we have a feature to enable the versioning properties. As of now, this is not enabled. If I go here, I can say add it. I can enable it, and we can specify any particular version control system. We can specify the URL, username, and the local path. And this is how we can configure the version control system for the MRS. MRS, which is configured with the version control system, only persists the latest copy in the database. All the historical copies are maintained by the version control system, which can be reverted back at any point of time later via the developer client flow. There are a couple of references which can be used in order to understand this further. Thanks a lot.
Hi, everyone. Please post your questions in the Q&A box. We'll try and answer them.
So you can put your questions in the Q&A if you have further queries. Okay, so how it works when you have to roll back some changes? That is one of the questions. So we can configure the similar kind of pipeline by making use of InfraCMD commands or the REST API in order to implement that logic. And that is how we can roll back the changes also. Okay, so another question is, how does the Jira know which mapping to be deployed? Okay, so from the Jira side, we have something called as the variables or the parameters, which we can set as a Jira issue, and that will be passed to the Jenkins, and the Jenkins pipeline will record those names or those variable values in order to be passed to the corresponding script. So here in our earlier demo, I was recording the mapping and the application name, which was further passed to the script, and that is how the script knows which particular mapping and which particular application need to be deployed. Okay. Another question is how it will work for multiple developers on the same workspace. So with the multiple developers, with the version control system enabled, there could be like either the separation will be at the project level or they are doing some team-based development. So while the development is taking place, definitely there is no continuous integration or the continuous development in place. But it will only come into the picture when we are deploying that code. So during the development, there is nothing, so to say, there is no pipeline which will be triggered. So it will only be triggered once we are making those issues into a particular state by saying that the changes are committed. Okay, so is there a step-by-step plan on how to configure the whole thing, including the shell script you showed? So for the step-by-step plan, I believe in the portal, you will be able to download this presentation, and this explains the entire process and what all the components are needed in order to implement this integration and the development part. Regarding the shell scripts, I will check internally if there is any way to share that. So another question is, Jenkins agent need to install on developer machine to trigger the object changes. So for the Jenkins, we can either point to the developer client tool or we can point to the server machine also, because it has to run infacmd command, given that you are going via the infacmd commands to implement the CICD. So, so to say, the Jenkins has to be configured on the machine where this infacmd is available. Otherwise, we can also make use of the REST APIs, which are not dependent on any of the operating system or the machine. So another question is, if there's any issue in the deployment through CI/CD pipeline, what is the rollback strategy? So for tracking, if there is any issue while running the pipeline, we can very well consult with the Jenkins pipeline. So every time whenever the pipeline is run, there will be a corresponding log generated from the Jenkins side, and we can very well refer those logs and understand what went wrong. Okay, so another question is there any example code for using the REST API method to export and deploy the code similar to the infacmd command? So in the admin console, under the DIS processes tab, if you click, you will get an option to go to that user interface where all these properties are available, and you can actually test your various queries via that particular user interface. Now, a question regarding the tagging. The tagging is a feature. Basically, you can make use of InfraCMD commands, and the tagging will allow you to tag multiple objects under a single umbrella. So that later point of time, you can query based on that tag so that you can fetch those objects. So another question is possible to roll back? Yes, obviously. We can make use of the similar architecture and we can make use of the InfraCMD command. So for example, like if you want to undeploy one particular application, which you are facing like some issue with, you can very well go ahead and trigger the undeploy commands also. So another question is how to implement flow like developer git version control and the Jenkins. Okay, so for that version control system is basically configured at the model repository service layer. So the MRS only stores the latest copy of the object, and all those historical copies will go into the VCS version control system. So any changes has to have come from the developer client too. So let's say if I want to go to some older version, it has to like go to the check-in and check-out we have to do from the developer client. And you can consult the command reference guide also if there are commands available for doing those same operations. If it is available, you can very well call them in the pipeline and perform those operations. So is there any KB article which I can refer? Obviously, this presentation will be shared on the portal. You can very well download. Apart from that, for a specific command reference, there are command reference guide on the knowledge portal. And there are KBs related to specific issues which you can very well consult. Okay, so another question is there any way to add a version number while doing a continuous deployment? Yes, we can, as I mentioned, in the Jira, we can very well have a parameter as a version name, which we can further use to pass the application and track what is the last version which went as a application patch. So there is an InfraCMD patch application command which you can very well refer. Okay, so another question is, in the current developer deployment wizard, there's the option to reuse or replace the object. How does it work? So I believe this question is regarding with the InfraCMD import object or the export object reference. If that is the case, right, we can very well use something called as a parameter file where we can specify what all objects to be filtered and what is the operation, whether the reuse or the replace operation we need to perform. So one question is is it possible to upload and send the deploy and export .sh file to the attendees? I might need to check with the internet team, and if possible, then I will definitely. So how to know which version is deployed in the test and prod? So usually in that application tab, we get a certain information about that application or the last modified and who has modified it. So one of the question is any template available for the Azure DevOps pipeline to implement the same? Usually the high level logic will be almost similar. We can very well configure the integrations, and the only thing is like the integration system will be different. In that case, it will be Azure development operations. So we can very well call those scripts no matter whatever that integration system we are using. The high level view will remain same. So only the some specific functionality might differ. So another question is where within the IICS administrative environment can I configure and test the API reference? I believe most probably you're referring to the DIS REST API. This is not in the IICS administration. This is basically the admin console, and then going to the DIS under the processes tab. That is where you can find out that link to go to that API reference for that REST API. So another question is about the how to track the changes, know when it is done and by who. In the admin console under the application tab, you can very well go ahead and check that who has last time when it changed.
Puneet, if there are no more questions, we can wrap up the session.
Sure, yeah.
Okay, yeah. So thank you, Puneet. Thank you, Praveen. Thanks everyone for joining the session. See you at the next Tech Tuesday's webinar.